Yep.
Sweet. Cool to be here. Okay, things are not always as they seem. We got about 265 slides to go through in the next 45 minutes or so buckle up. Here we go. I'm Stök, this is Joohoi, and we're actually here because we're on tour for the release of our new album, Pure Scandinavian Darkness. Thank you. I mean, these guys think it's totally sweet, too. and now I'm just kidding around. We're here because we're going to talk to you about bitflips. We're going to talk about space weather, heat, voltage, and other weird stuff that makes our devices go haywire and somehow fetch resources that they weren't supposed to, or leak credentials by sending post requests to places that absolutely weren't supposed to send them, or emails that end up in places where they absolutely shouldn't be. Like this wonderful Slack invite, for instance. I mean, if we dig into this email address here, we'll see that, isn't this email a little bit like close this domain? Isn't that close enough to, oh, it's jumping too fast. Isn't this very close to the domain that the company that we work for?
Yeah, it is actually. But in this case, it's actually a typo. Obviously, Q is next to the A in the keyboard, and that's basically what you get with a misplaced hand or typing stuff in a hurry.
Right, but that's not why we're here at all, because we're going to talk about bitflips. And the really cool thing with a bitflip is that all it takes from one single 1 to turn into 0, or 0 to turn into 1 to change everything. Because the thing is that if you take this domain, for instance, google.com, by flipping this little character here, this 1 into 0, it turns into google.com. Or if you change these two, it's google.com. And if you change both these two again from 1s to 0s, well, then it's google.com. Speaking of W, I mean, WordPress, if you flip this bit here from 1 to 0, WordPress turns into GordPress. And GordPress is a really cool domain that you could actually go buy if you wanted to.
Well, not exactly. So we did this talk originally at Black Hat, and a couple of days after our talk, the domain was gone, and it was not us.
So somebody else decided to buy it. That wasn't us. So kudos on you, GordPress owner. And this technique is called bit squatting. And that was kind of coined by a researcher called Artem Dinenberg. And he done this great paper around how this works on DNS and everything. And instead of reading that, we're just going to read the fact place called Wikipedia. And I'll help you understand what it says. More or less. And I'm just going to read this straight out. Bit squatting is a cyber squatting which relies on bitflips errors that occur in the process of making a DNS request. Going out, right? These bitflips may occur due to factors such as faulty hardware or cosmic rays. Interesting. When such an error occurs, the user requesting a domain may be directed to a website registered under a domain name similar to the legitimate domain, except with one bitflip in the respective binary representation. I was told this by my friend Dylan A. that he wrote Trufflehog, and I got super nerd sniped because he said he registered googleapis.com, which is extremely close to googleapis.com. And due to the fact of space race, that's what he said, he collected shitloads of loot. In that fact, it's API tokens, and it's all these lovely JavaScript interaction coming his way. And at this stage, I'm like, ooh, I want to know how to do that. So I was like, how can I do this? So, well, obviously, it's very simple. All you need to do is to buy a bunch of flip domains. Then you need to catch all the DNS requests coming in, write some simple code, and then store it into a log file.
Easy, right?
Super easy. Well, since all of you are super smart people, I'm just going to go through the research and the way that it was approached by Artem back in the days, because I'm not super smart, but I had to figure things out, how they kind of worked. I'm having a bit of latency here.
Okay.
It's not showing up on the stage. I don't care about that, though. So, let's just figure this out. Let's say that I have this client app, and it's going to do this authorization kind of flow. And what it's going to do is that what happens in this case is that, well, it's going to talk to the upline. It's not working again. Delaying. We can live with that. Anyway, so it's sending it to this upline DNS server, right? And the thing is that that upline DNS server is going to be polite enough and then respond back with, every click I do, it doesn't display all this on screen.
This one works, though?
Yes, but I'm the same.
Okay, let's see if mine. No.
Okay. TV engineer, there's a latency in the output. I don't know why. We can live with that for now. The problem is that I'm not even sure what's going to be shown on the screen, so I'm kind of guessing. We're good. Anyway, so it's going to ask the upline server, that's going to respond back with a name server, and then what's going to happen is that that response is going to send back to the client is going to be super happy, and then collect to that web server, handshake's done, voila, everything's all good. Well, imagine for a second then that this kind of happened. A bitflip happens mid-traffic, and this lovely domain that we have here, WordPress, well, and that flips in the memory of the device. And so now WordPress turns into WordPress. Sweet. Same thing is going to happen. It's going to talk to the upline DNS server that's going to be sending the request now to the name server authority of WordPress.com instead. It's going to respond back with the IP address of that host, and then the client's going to say, oh, that's so super sweet. I want to make sure that I send my traffic over here. So when it does that, that post request is going to end up in the other kind of system, Sketch. But then again, this worked perfectly back in the days over HTTP. Nowadays, if we would do this, other kind of things would happen, because this would pop up, because we got HTTPS now. So the research that Artem did hasn't been really functional for the last 20 years or so, but we're cool with that. So I figured that to be able to then break this HTTPS kind of situation, that means that we need to have a certificate that's trusted for our domain. And just to break down how certificates works, because this is an important part of the whole TLS conversation, later, a Saas certificate could contain multiple domains or subdomains that is going to be presented by one certificate. You can create those. If you want to have more than those that you have predefined, you need to move into a wildcard certificate, because the wildcard certificate in this case, what it's going to do is that it's going to make sure that all these first level, like www, blog, and dev API, that's going to be able to be served by that certificate, which is great. But if we had this authentication line here, so auth.devapi.wordpress.com, if we get that request coming in, what's going to happen is that it's going to be super sad and not work.
Again, because wildcard certificates are good only for one level in the subdomain, basically tree.
And the challenge today with modern cloud infrastructure is you've seen those long URLs. It's like something.something server.eastus.something CDN. It's a lot of guesstimation about what kind of request is going to come in. So in this case, if you wanted to have like all each level that you want to secure, you need to have one for each and every sub-level that you're in there. In this case, it's going to be one for WordPress.com, one for devapi.wordpress.com, and here we are again. I mean, it should be easy, so reality is like it's not that easy. So I figured to get this up and running, what I had to do is to, first off, in this project, I had to buy the right domains. Then I needed to set up a by9 catch-all DNS server that loved everything that I gave it. I set up a Nginx with a proxy that pointed over to my really shitty dynamic flash code, and then stored hits in multiple different log files depending on the domain. And then I got some Let's Encrypt certificates. And the certificate part is interesting, because that required me to have this. First of all, I needed to kind of figure out what certificate I wanted to have. Then I needed to add those in text records of my by9 one. I needed to configure my web server proxy thingamajiggy to understand that that works. And then I needed to be able to sign those, also have these known like app routes to prove that I'm actually the owner of this domain. So that was a process that I was able to keep up for a short while, because the reality is that I needed to renew these manually every 90 days. And that was too tedious for me, especially with the whole guessing part. So I figured I'm going to automate the shit out of this. That's great. But at this time, I was so tired of the project that it's like, this is what all the thing that ended up, and I went on to do other things, like sunbathing and stuff. So here we are then. I mean, 2 years passes. I forgot about the project, because that's kind of the nature of the beast. Boring project, forget about it. Until one day when I got this super nice email from my VSP provider, like, dear valued customer, your VPS Flipper McFlipper face is running out of disk space. I'm like, that's super interesting. What is this? Like, that's so cool. So I logged into the box, and at this stage, I'm like, they're actually out of disk space. I wonder what's in here. And then I realized I had the log files, because I keyed everything into these huge log files. And that file was with an understatement, and that was a really, really large one with shitloads of loot in it.
So yeah, meanwhile in Finland, I love self-hosting. I've been doing self-hosting for the better part of last 25 years, and this is a small story about that journey.
Masochist.
Yeah. So in this story, we are going to use...
You have to go one forward and one back. It's that ridiculous.
Okay. So I'm going to use, as an example, I'm going to use domains that were not the part of the real world story, because it includes some entities that we're not too happy about having their name released. So yeah, for the sake of this story, we're going to use domain l0.fi and lo-fi, so we can have cool graphics as well. So yeah, the story begins there. Starting with me registering a short domain, l0.fi, just for my personal use. And something that I do when I set up my personal domain, including emails and stuff like that, I'm going to set up a catch-all email. Basically everything every email that is coming to that domain ends up in my inbox. And this allows me to basically create a unique email address for everything that I end up using. And when eventually my data gets sold or something nasty happens, I'm just going to be able to block that off from MTA side and be good. So I did this setup like I do. And emails started flowing in, everything is nice and dandy. And I'm starting to get emails for a bank. So this is definitely not meant for me. Email for some random bank person. And I was wondering why that may be. So my domain is l0.fi, but turns out in Finland, we have quite a large bank that has a domain lo.fi. And this is, typo stuff. And yeah, so basically now I am every person in that bank, every support address that they may have for everybody that makes a typo for the address. And looking at the keyboard, O and 0 are basically right next to each other, and they are also visually alike. So that's where the problem stems from. So I do whatever a responsible security researcher does. I try to contact the bank security people. Hey, I have this problem. I'm receiving a lot of email, and a lot meaning I got a 20 plus emails per day with the PII, bank details, stuff like that. And I would like to get this fixed. I don't really want to be the responsible for people's bank stuff.
You didn't really sign the PII thingy, right?
Yeah, exactly. So I sent the email out and waited, and nothing happened. No response whatsoever. It is not a thing that has an easy technical fix. And I think that they were probably scratching their heads about how to deal with this. So I pick up a phone. And I try to call them that, hey, customer service person, funny thing happened. Could you please connect me to somebody that could help me with security stuff, and trying to explain that stuff. And they were like, no, and no. So basically, days and weeks go by, no response from the bank security. And I receive these emails, and there are some odd ones in the bunch at the same time as well. So you probably know what this bad boy is. Yeah, it's a scanner. It scans stuff. For example, in a bank context, probably like a contract detail, stuff like that. And they are used all over, at least the kind of more analog world, when stuff is still on, where stuff is still on the paper. But it doesn't end there. If you plug it to a network, it can also send stuff. And send it did. And if you're working at the bank, IT, and have one of these things running, you probably want to make sure that it's configured correctly. Well, this one wasn't. And now I'm getting the contract details for every scan that is happening on that scanner. And I was like, crap. I really, really, really don't want to deal with this, but no response from the bank security, so here I am, sitting and waiting. So, again, days go by, weeks go by, months goes by, and summer comes along. So what do you do at the summer usually?
You go for vacation?
Yeah, to a hacker camp. So there was this hacker camp called Saas 2017 in Netherlands that summer. I was there. And there was a bunch of people all over the world, basically. But I met some Finns from a Finnish CERT run by Traficom. And the Finnish CERT is super awesome. They are basically part of the whole hacker community in Finland. And they do their stuff really well. They are able to connect us. And I told them about the kind of high-level thing, what was happening, and they understood the impact, the issue immediately, and okay, we have a hotline to the bank. We're going to connect you right away.
Here we go.
And I was like, not really. I don't have my keys with me. I cannot access my email infrastructure from here. So let's just wait this party over, because it's like and follow up when we get back home to Finland. Because, yeah, they have been sitting on this for 5 months already, so 1 or 2 days more doesn't really hurt. And they delivered, like they always do. They were able to connect me with a lawyer. So, to be honest, the lawyer is the person appointed by the bank side to handle this thing, not by the Finnish CERT. But to be honest, the discussion was really good, really civil. They understood the issue, and basically the only solution that we could co-op there was just me giving them the domain and basically get rid of that stuff. There's no real technical solution for that, and so on. So this is really where the story should end. But it doesn't. So a couple of years in the future from here, I register a new short domain, ki.fi. So the previous one was L0 and the bank was lo.fi. And I set my stuff up. Lo and behold, the bank is back. So, but why ki.fi? Really? Like, what is the problem this time? Well, taking a look at our good friend, the keyboard, it is one-off error. Misplacement of a hand. And, yeah. At this point, I fortunately already have a high bandwidth connection with the bank security, and I'm like, hi guys, it's me again. Never guess what. But this time around, I was like, okay, I really like there's no real reason for me to give up this domain. I want to keep it. It's actually a cool domain. Can't tell you what it is right now, but it's a cool one. And yeah, they understood the issue. And yeah, okay, we're gonna have to take this to our risk department and figure out what's going on. And they did. And I'm not sure if it was because of this or like other stuff, probably other stuff. But quite soon after, they did the most awesome thing when it comes to the bank communication for PII, email, all of that. And that means getting rid of the email altogether. All the customer communication nowadays happens within the web application or mobile application of the bank. So email is off the picture, and things are good again. And this is where the story actually ends.
But it's also like the beginning of something else, because even though he likes his self-hosting, we met up at Disobey, and that's a security conference in Helsinki, and since we're good friends, and so I just wanted to share my loot that I found and the project that I've been building on, and I explained to him like all these things that I had and that it didn't fully function, and I was challenged by a lot of like, since I know Jonah's been working with Let's Encrypt and all that through the EFF, it was like I was asking him about some certain things, the designs that I wanted to do, and we started to dig into it. Like, is there any way for us that should we just dig into all this and just try to fix it?
I mean, there's a lot of things in this like combination that we can ease up with like added automation, adding a bit of a blue tack somewhere or a tape around something else. Or the other way around, though, we could scratch all of this and write everything from the scratch, the whole software stack.
But bear in mind, we're like 3 or 4 NEPAs in here. It's a very smart idea.
And I mean, like, we're not young guys anymore. Like, it's a lot of work for a research here. But I wonder, should we do it still? Remind you of 3 NEPAs.
Yes, of course. Yeah, let's do that. So we scrapped everything that I had and then decided to, let's just build everything from new. So what we ended up doing is to build this custom DNS server, custom HTTPS server, custom mail server, a certificate management solution, payload, then a solution that has custom payload injection capabilities, support for multiple protocols. It has an extended config file, so you can configure it exactly the way you want it. And it has a JSON format for log files, so you can parse that into whatever kind of solution you want and parse into JQ, and it's lovely. And it has the most amazing thing. It takes you 5 minutes to set up due to a Go binary, and you don't need to do all the things that took a lot of time for me. That was obviously, that was shitloads of work. That took us a long time, but it was the birth and reality of Certainly. And Certainly is a tool, an open source tool, that listens to all incoming requests and says yes to everything. And it does this by the capability of delivering on-the-fly SSL certificate generation. And they also have this great possibility to perform injection of custom payloads in an upstream kind of thing, which is super cool. But also it's a first-class credential logging service, so if you don't know where your credentials go, at least we keep them safe in our log files. And just to explain like the architecture around how this works, let's get back to this good old baby here. You remember the bitflip happens in the device, and then it suddenly turns W into G, and it goes to WordPress instead of WordPress. Now, what's happening is it's still going to do the inline first DNS lookup, but the request is going to hit the Certainly box. And here Certainly is all happy, shiny. And what it's going to do is that it's going to respond back to whatever kind of DNS request set it with the IP address of that customized box. Or another box if you want to. It's an option to do that in the config file. And Artem's previous research, he was a little bit bolder than us, and he said, like, the best way to get maximum impact of this is to have DNS poisoning, which means that you will not only answer on the flip domain, you will match on the matching domain as well with an IP address. We like, sweet. Then we realized the hard way that it's super dangerous and the internet dies. So we implemented 1 second time to live instead. And then we removed that code part from the open source project, but it's an open source project, so you can add it if you want to, but that's on you, not on us. The capability is there. So then what's certainly going to do, since it gives the nice IP address coming back, well, the client is then going to be super happy and then connect to certainly, and the TCP connection comes in for the first time, and now the magic begins.
Yeah, so this is where we go into the whole TLS flow. So the client asks for a specific certificate starting. Basically, the TCP connection gets initiated. The client sends the client hello, telling the server which domain it's trying to.
Totally unknown for the host. Never hit the host before.
Yeah, exactly. So we really don't have the certificate ready to serve for the client. So what certainly does is telling the client to hold up. So it's pausing the TCP session, and meanwhile, in the background, running to the CA.
Nice.
Okay.
There we go. One more.
Okay, running to the CA and asking certificate for this newly found subdomain. So please, could you hurry? I have a
I'm a bit in a hurry.
Yeah, I'm in a bit of a hurry. I need to...
They're holding the session.
Yep. Stay there at the same time, like making sure that the client doesn't time out, obviously. So yeah, I need to serve this certificate for my loyal customer, and I'm in a bit of a hurry. So could you please help me with that? CA will happily help you if you're able to prove your ownership of the domain. And certainly able to do that because it's also the DNS server at the same time. So answering these DNS challenges is a piece of cake for it. So it is able to validate its ownership like any normal Acme flow would do that. And prove that to the CA, and the CA will happily sign the certificate and send it to Certainly's way. And this is where Certainly is able to release the TCP session again and answer with a valid certificate in roughly 4 seconds.
Yes, it's fast. So now we have this nice certificate. Session is getting released because this is the TLS connection that the client was kind of expecting, because we have the certificate in place now. If we already know about the first part of that subdomain, obviously we're not going to generate a new one because we're doing wildcard certificates here. But that gives us a great possibility to always fetch it on the first try.
Yeah, I mean, bitflips, they happen quite rarely, so we need to be able, in order to collect all of that sweet loot, we need to be able to answer or handle even the first request coming in with the same care than we do with our returning customers.
And I did that manually in the beginning, it was tedious. So what then happens in this part is that since the client really vibes with this, like super secure connection, then it's just going to post whatever kind of credentials that came its way. Bob's your uncle is going to be sent to Certainly. Certainly is going to store that into the logs in a nice JSON format. And then what it does is that it's going to 307 politely to the original host, walk out of the way and leave the connection over to the original host. Just being in between for a while. And what's really interesting with that is we realized that if you treat your customer with respect, they seems to become this called like a returning customers. So they come back, not one time, multiple times, because it seems to end up in some kind of caching thing, depending on who built it. So then we thought that this is cool and all, but how about adding some injection support? Well, we could do that, and that flow would work this way instead.
Yeah, so obviously we are in the control of the whole communication flow there. The client comes in, asks Certainly for a resource, and Certainly will yet again ask the client to hold for a bit. And while the client is holding, Certainly will pick up all the request headers, append them, mangling them a bit if needed, and send a background request to the original host that we know of.
Look at us. We are you now.
Yeah. So we're basically now in control of bidirectional communication here. And we are obviously grabbing the response, including the response headers, appending those to the response to the original customer of ours. And yeah, the request or the response may contain something that we may want to juice up, so to say. So we're able to basically substitute stuff in the responses because we are in the control of the whole flow. So now it is spiced with some evil and nasty stuff that we're able to send back to the client.
Isn't this like great? Fully customizable, templateable, you can figure out how it works. Fun, there you go. But I hear you're thinking back there, it's like, yeah, cool and all, but how do I get the domains? What should I do? Well, Luke Young did this great presentation on this at DEF CON 23, and he finds a way to get a lot of domains really cheap, and he also released a tool called BF Lookup. And this is great. It's a small Go thingy that what it does is that you put in the domain and you're going to get a bunch of responses coming back with the name servers that are currently taken. Or if you have stars, it's open for registration, which is great. So in this case, when we ran this the first time, now obviously WordPress is registered, but it turned out there were 28 possible bitflips for WordPress domains available to purchase. That's not that expensive if you want to. It's like 10 euros a pop or so. The real price and the cost comes when you do this long term, because the renewal costs for these are, that's quite steep. They get you the second time around. So
it's a subscription for mischief, basically.
It is, and it's expensive. So we needed to find a way to, how can we approach this in a way where we could kind of funnel down which domains to buy. We don't want to buy all of them. That was expensive. So I digged into this great research here that was presented by some super smart people, and they really broke everything down and more or less did shitloads of calculations on if it's more likely that a 1 will flip from a 1 to a 0 or the other way around. And in their research, they found out that, well, it's a bit of a higher probability that a 1 will turn into 0. And the main fact that this happens is somewhat unsure to me, but it's something like keeping a charge. It requires more power on the device than just letting it go.
Electricity and magic, like everything else in the IT industry, right?
Right. And so I figured, okay, which are the characters that are DNS compliant that has the most ones in them? Well, it's O and W. And then what's really interesting here, that if you have a bitflip changing here, there's also a high probability to have something called siblings. Because one character, O, for instance, can turn into both K, G, M, N, and L, W, V, S, G, C, P. And these are just the two characters that we're focusing on right now, the ones that has the most ones. But there's just not one or two of those. There's a shitload of different other characters that have this kind of setup. But O and W are the ones that we're going to focus on today.
And you guys there at the back, are you able to see the last line? Okay, good. Perfect.
Otherwise, lasers might be a good idea. But there's also these other ones that have the most zeros, because we are interested in the edge cases here, the ones that actually could do some damage, and that's A and B. And if we're looking into, let's say, WordPress.com here, if we will change any of the ones in this row here, it's the third row from the left, and people that do see calculated differently. But if we change all that to zeros, well, that's going to happen is that only going to change if it's a lower character or a higher character.
And DNS doesn't really care, so.
Not at all.
Yeah.
So if you look into your logs and you have these kind of late-looking domains, it's not somebody trying to bypass stuff. If flips happened. So those are really interesting. But if you approach it this way instead, like these three ones here, what happens if we change those into zeros? Well, the domain is going to be that does not resolve due to the fact that CMM is not a valid TLD. And you can see that the B here turns into a backtick. And backticks also is a bit problematic when it comes to DNS.
Yeah, I mean, like in offensive security, we allow backticks, but in a different context, doesn't really work on the DNS level.
But it's a good thing for you to remember, Bs can turn into backticks because who knows when you're going to fuss and break stuff. Nice. And if we look into these domains that we had to play around with to begin with, like this is WordPress and this is GordPress. The only difference between these two is one single bit changing. That from 1 to 0, that's all, inside this whole binary string. So since we now know that, the most ones and are the most probably to flip is O and W that have all these kind of other siblings. Which of those are most likely to flip? Well, we did some research on that too. So it's, in this case, you see that it's K that is the highest probability due to the data we collected over months and months and months to flip. And I don't know why, but it's just that's a high probability flip. So if you're going to buy something, switch an O to K. All the rest of them are also super valid. They are high probability flip characters. And if we looked into the BF lookup, some other smart person actually had already registered that. They were ahead of us. But there were all these other ones that were available to registration. In this case, it would be WordPress, GordPress, obviously, somebody else took, and those other ones. I have no idea if they're gone now, but hey.
Yeah, for transparency, we weren't targeting WordPress in our research.
No, it's just an example. Who do you think we are? Criminals?
So, so you may be thinking that nowadays with all the turmoil and the geopolitics and all of that, what if we could do the same thing for the TLDs, the TLD part of the domains?
Yes. I'm happy that you're asking, because what we could do is go into this whole list of the IANA.org and see the current TLDs that are available. And there's actually right now, I think it's like 1,447 minus the first line, so we got 1,446 TLDs. Me being the super smart, new and innovative person, asked ChatGPT to take all those, compare them, write the Python script for me, and so I can compare if there's any matching pairs among these TLDs. And it actually shows out that it's 348 of them that actually turn into something else. They're all valid. Interesting. SE turns into .ru. Wasn't that the thing?
SE turns into SU, that is basically old Soviet Union country TLD, still controlled by the Russian Federation. Yeah. But yeah.
Who knows, right? And, but then again, we have .io, very common with Web3 people and devs and people. That turns into .im. And .im, well, that's the Isle of Man. And anyone can register a domain like that in the Isle of Man for the hefty price of 20 euros. Super cheap for a year, good for research. And somebody else obviously, already bought like metamask.im that I was pretty keen on getting. So that was already taken. But I'm now the proud owner of shitloads other domains that are flipping. Because the interesting stuff here is now you're not flipping one domain. If it flips on the TLD part, like we saw in some cases it could, I get all the loot. So an interesting domain that we all then kind of wanted to have was .com. I mean, that's like the crown jewel of everything. And it shows that .com actually flips into .bom. And .bom is a new and upcoming domain from a Portuguese kind of thingy, I don't know, but it's the Portuguese word for good. And what could be even better than being the proud owner of now the pre-registration of Amazon.bom?
But I wonder.
You think that's going to get approved?
Yep.
But at least I was there. So, and if we then approach this again with the other methodology, and it's like, okay, the most possible to flip was O to K, right? .ckm, that would be cool. But is that doable?
Yeah, it doesn't exist today. But there is a way to actually request for that stuff, for vanity GTLDs, basically from IANA. But it's not exactly cheap, 185K, and that is not for it is not a purchase.
No,
it's the cost for evaluation. So in case you're going to like chip out that sort of money, you want to be pretty sure that you have a pretty good justification why you or your organization should have these GDL.
These happen every 7 years. And now is the time to start a multi-million kind of company that you can prove that you should be the owner of a KCM. Because there are other companies that did this for us, like .Nike, for instance. Nike have that. Flips to .like. Go crazy. Anyway, we promised you that we should talk about the cool stuff, the cosmic space stuff, because that was the whole intention why this project even started. I was so into space weather. That's cool. So now when we created Certainly, and we have that up and running, we wanted to replicate kind of the results of the previous research, obviously for science. And we approached the methodology by using bit squatting, the Artem style. We registered about, what could be like, 25 domains that we bought. And then we, those 25 domains belong to different like cloud, Saas provided package repos and other providers that most of us use on a daily basis. Because we wanted high traffic, high bandwidth domains.
Yeah, reminder, it's happening still quite rarely. So we want to target something that is high traffic.
Yes, so the more things that happen, the more likely it is that you get some loot. So we let this puppy run for about 4 months and 23 days, sitting there just hoping for space weather. Man, did we get lucky? Because here, on May the 10th, 2024, the Earth was hit by the strongest solar storm in over 20 years that created so much havoc, theoretically, to all these kind of different things. So me and Jonah, we're sitting there, and we didn't know for how long this storm is going to last. So we like committed and say like, we're not going to look at the logs. It's going to be amazing. So this is like us, like, not today, not today.
And yeah, sure. It was basically a weekend-long storm.
Yes.
Solar storm.
3 days.
Yeah. And after it passed, we were finally, okay. Now it's time to take a look.
Yes.
And look, we did. We saw nothing. Actually lower than the average.
Like, what the fuck?
This was supposed to be the cool part, right? Well, apparently not. So we were going to, we were flying to Las Vegas in August, giving this talk in Black Hat, and on our way there, we were like still baffled about this thing, like looking things up, and stumbled upon a new research that was released, a white paper that was released just a couple of weeks prior to our trip.
And at this stage, we're bummed out. We're sad puppies. We thought that like we did something wrong.
Yeah, but no. So this paper is basically looking at the correlation between DRAM errors and cosmic rays, and it's not just a couple of random people. It is actually researchers from Barcelona Supercomputing Center, European Space Agency, and University of Athens.
Smart people.
Smart people with a lot of data. And in the conclusion of this white paper, they point out that they detect no correlation between the DRAM errors and the cosmic rays. And they go even further and to suggest everybody to revisit their research from the past years. That is kind of suggesting this.
Because it's so heavily ingrained in us. If you ask anyone, like bitflips, they're going to say, yeah, no, that's space, you know. Can't do shit about it, space. So, but the fact kind of remains. Like we're digging into this, and we're starting to realize that the facts here are that we did, on this period, actually collect 62 million DNS requests coming in on the domains that we have. And we also got about 2.8 million unique, valid HTTPS signed certificate requests coming into our server.
And we were able to serve these requests. Those are actually successful requests.
Yes, there were some ones that weren't as successful, but this was the amount that we had. And then We also had like about 15,000 emails coming in.
That's a lot of Viagra.
Indeed. But there's a shitload also like meeting invites or forwarding to things. Like you flip the middle and then you have a reply all to everyone. Like it's very, very interesting data collection.
And maybe you remember this bad boy.
Oh, yeah.
He's back. So we're getting scans again. Not the bank this time, but some other stuff. PII probably. So we're trying to play nice here as well, like not storing that stuff. But
people doing their scanning kind of thing. Can we get the email for some reason? I don't know why. But hey, sketch. Anyway, but that's just one of the parts, because what's really interesting here is that we also connected about 2.3 thousand unique OAuth and authentication tokens that were valid. It's not the fake admin kind of bearer shit, because these are things that actually belong to multiple, like Fortune 500 companies that were using these SaaS services as their own. I smell supply chain issues.
Yeah,
but it's
sure.
cool.
Yeah.
So, and that is, and we reach out to a lot of these companies and explain to them, and it's a hard nut to crack. But we also realize that if you're doing offensive security research and you want to figure out kind of the attack surface of your target, register a flip domain and then just get all the DNS requests coming in, because these doesn't need any validation.
It gives us the visibility over, like for example, a split horizon DNS setup where you're able to kind of get different answers to different domains from internal network than from the public internet. And if a flip happens, we basically get the information directly to our
And it's great for creating brute force word lists,
yeah.
we realized. But you also get shitloads of traffic by the scanner boys, because as soon as the certificate is getting registered, they are pulling that nice little feed and they send the troops coming. So it's also a good thing to either get the latest and the greatest payloads that people are spraying, or two, knowing who actually is poking or throwing stuff at your attack surface. So it's like both ways here, so you know how to mitigate it. And I mean, seriously?
Yeah, you're probably thinking that, okay, those two weird guys from Sweden and Finland, like doing a bitflip research, like what I'm supposed to do. Like, is there anything that I can do to protect my stuff or the stuff that I'm basically responsible of? Well, the first thing, obviously, taking responsibility, like with every or any security thingy that requires some work around it. So, obviously, the initial thing that you can do is buying off these domains that are basically free and one bit away from yours.
WordPress actually seems to be able to buy one.
Yeah, they got one. But there's probably some still left for WordPress, but this is not really the kind of good approach if you want to go that route. So don't be like WordPress, but be like Amazon. They got all of it. All of it.
The renewal cost, though.
Yeah, the cost of doing business, I guess. So then, obviously, cert pinning. So cert pinning doesn't really work for like your traditional browser-based communication, but it's still a valid thing for mobile devices, mobile applications. It's deprecated for a reason for the traditional browser stuff, but there's also the fact that we are actually seeing an overrepresentation in the mobile devices in our data. So the bits are more likely to flip on a mobile than on good old computers, desktop ones, or servers, that is. Servers, actually, they have ECC RAM usually, so yeah, that's also.
I think we got one, and then potentially a false positive.
Yeah, but also, when you're implementing certificate pinning, especially in this context, in order to protect against this threat, you need to be really, really careful to implement it right. So, we obviously saw a lot of data, and we were talking with a couple of companies that basically showing that what we found, as you mentioned previously. And they were like, hey, but and our suggestion being like, implement certificate pinning and get rid of this thing. And they were like, we actually do certificate pinning already. We were like, okay, maybe we should look into this a bit further in order to figure out what's wrong then. So yeah, they implemented certificate pinning. So they basically listed all of their domains. They had a map, or they had a map of their domains and the certificate fingerprints that they're expecting those to return, which is a kind of, that's how you sort of do certificate pinning. But if the domain is not found in the original list, they would fail open. Basically meaning that, okay, yeah, sure, like all good, go ahead. You're not one of those domains that we want to do certificate pinning on.
It happens in the memory of the device prior to the request going out.
Yeah, exactly. So the device is actually, the client device is expecting the certificate for the flipped domain instead. And one of my favorites is actually following the BSD, OpenBSD thing, with OpenBSD pledge kind of philosophy here, where you basically, upon the application initialization, you have the same, like these domains are fine, and then you do hashing or stuff like that. And when in the certificate validation phase, you would basically then go ahead and check this. And if it doesn't match these domains, then you just kill the connection and get rid of the problem altogether.
Yes.
But this is something that needs to happen in the programming language core libraries and requires an extra step after that from the developers. So don't hold your breath. It's not going to happen tomorrow. But yeah, this is probably the kind of best long-term solution on the application space that we can do.
Or you can approach it like some of the providers did. You can blame it on DNS, like we always do. And then you can live on all blissfully and keep on ignoring it. But fact remains, this is happening way more than we thought it would. So, I mean, no way or shape blaming it on you, but hey, I'm just going to keep on getting you credits as long as you live by that purpose. So I kind of figured that you're also kind of wondering here, but why is this happening then? If you have all this data, we kind of need to know. And the truth, honest truth, is actually, I mean, we have no idea. Because
it was supposed to be space weather, right?
We thought there was space weather. So that's why this is a call for research. Because the whole conception that people think that this rarely happens actually is probably more due to the fact that, it actually rarely
got caught.
Yeah.
You just didn't observe it. So,
but using certainly, since we can get each and every request coming in now, we're changing the game a lot here.
Yeah. So obviously it's happening most in like mobile devices, mobile applications, and it's going to be something row-hammerish, right? With a small form factor there, flips happening, and there's no validation or verification of that. No easy memory in my pocket. So that's the thing.
Right, or it could actually has something to do with the CPU or the CPU cache or the memory channel or the network libraries or any kind of network.
Snipe. Snipe. So yeah, we definitely got sniped by the whole concept, the whole idea. Spent a lot of hours around this, writing tooling, doing the research. Figuring all of these things out, but I hope that this talk may have given you the same effect, getting your brain racing. What can we do to kind of, what is this thing?
Right, and that's why we have decided to, we released certainly OpenMIT, so anyone can get into this and poke around with it, explore with it, play around and see whatever happens. Or you can just use that TLS signing solution to, hey, always get good certificates in a way.
Yeah, it's, yeah. So yeah, it's there's the URL, github.com/happycakefriends, because we're not malicious, right?
Not at all. We have a lot of cookies. And since we are official things, we also have stickers.
There's a couple, yeah, there.
And that's pretty cool. So this is Joohoi, and I'm at Stök Joohoi on all social media. Thank you for coming to our talk. So time's up, and there's going to be no questions, haha, on you. So I'll see you. If you have any questions, let's meet in the bar later on and just have good times, because now it's nothing stopping you between us and the bar.